Okay, so good morning. Good morning, students. Okay, so we were talking about structure of atom, right? Can any one of you tell me what we have discussed? Dikshit, yes. So what we have discussed in the last class, some points. Okay, line spectra, very good. So we have discussed about the line spectra, right? So what are the examples for line spectra? Absorption spectra, and emission spectra, right? So that's what we have, absorption spectra and emission spectra. So these are the examples for line spectra. Yes, very good. That's where we have studied. So what do you mean by absorption spectra? Absorption spectra means these are the radiations or wavelengths of radiations which has been absorbed by the molecules. Right? They are called as absorption spectra. So what will happen whenever there is an absorption? So whenever there is an absorption, so electrons from lower energy level, it will move to the higher energy level. Depending on the energy it has taken, it will move from lower energy level to higher energy level. So that's where we have the absorption spectrum. Yes, we have discussed about absorption and emission spectra. So what is mean by emission spectra? Emission spectra means these are the wavelengths of radiations which has been given by the molecules, which will be emitted by the molecules. So that's why it is called as emission spectra. Now in case of the emission spectra, what will happen? So in case of the emission spectra, electrons will come back. Electrons from higher energy level, it will come back to lower energy level. All of you have understood? Fine. So if I take n is equal to 4 and n is equal to 1. Here it is, n is equal to 1, n is equal to 4. If you observe it carefully, what is happening here? In case of the absorption spectra, electrons are moving from energy level 1 to higher energy level, or energy level 2 to higher energy level. It depends where the electron was located in the beginning. Okay? But here electrons will come back to ground state, or electrons are moving from higher energy level to lower energy level. So one thing you should remember, energy level is going to increase as there is an increase in the n value. Energy level is going to increase as there is an increase in the n value. Okay, so all these things you should remember. So that's what it will happen in case of the absorption spectra and emission spectra, which will be like a fingerprint. It will, both of them will be like a fingerprint for a compound. Fingerprint for a compound or element. Compound or element. Why? Why they are called as fingerprint? Because each element or each compound, they have their own specific pattern of absorption spectra and emission spectra. Okay? So why each element or compound they have their own specific absorption or emission spectra? That is because their distribution of electrons will be different. Each element, since they differs from each other in their atomic number, so therefore they differs in their nuclear force, they differs in their distribution of electrons. All of you have understood? Fine. So that's what we have discussed in the last class. Okay. So then we were discussing about the energy of these energy levels. How to calculate energy of these energy levels, right? So to understand that, we should know the equation. So don't worry, no requirement of derivation and all for your this one. Only equation you should know, that also to solve the problems and all. Okay. So which is that equation? Equation will be En is equal to minus RH. Please remember, if you observe the RH, I have written R, capital R, and subscript will be capital H. You should not write RH like this. Okay, it's not acceptable. So that's where we have the RH, Rydberg's constant. That's where we have the Rydberg's constant. Then, along with Rydberg's constant, we have the Z square and N square joule. N square joule. J stands for unit. J stands for unit of energy, joule. Because RH is having same unit, joule. So therefore we have the joule. Atomic number does not have any unit. Number, energy level number does not have any unit. So this joule came from Rydberg's constant, which is nothing but the unit for the energy. Right? That's what we have discussed in the last class. Okay? All of you have understood? Yes, you people are right. So that's where I have Rydberg's constant, atomic number, energy level number. If n is equal to 1, then I should write it as E1 is equal to minus RH Z square divided by 1 square joule. Right? If n is equal to 2, then I should write it as E2 is equal to minus RH Z square divided by 2 square. All of you have understood? Now if you observe it carefully, no need to by heart anything. If you know this equation, you can tell the whole story. If you observe it carefully, energy of energy level 1, naturally it will be less than that of the energy of energy level 2. What is the reason? Because there is an increase in the number. Since there is a negative value, so in the denominator, as there is an increase in the value, the whole value is going to increase because it is having negative sign. It's a simple mathematics. It is a simple mathematics. All of you have understood? Okay, see, for example, I have 1 by 2 and I have 1 by 10. If someone asks you which is the larger value, definitely we are going to tell 1 by 2 is the larger value. Right? But the same thing if I ask it as minus 1 by 2 and minus 1 by 10, which is the larger value? Now I will tell that this will be the larger value because there is a negative sign. There is a negative sign. So as there is increase in the value of denominator, the value is going to increase. Right? Yagnesh, what is that 10? So whenever we have the positive value, whenever denominator is going to increase, the value is going to decrease. Whenever we have the negative sign, as the denominator increases, value is going to increase. It's a simple mathematics, basics. All of you have understood? Same logic is applicable here. Since there is a negative value, so naturally, as there is an increase in the energy level, please remember, one statement I can give, remember all these things. As there is a increase in the energy level. Energy level. What is that energy level? It will be represented by N. As there is an increase in the energy level, there will be increase in the energy. There will be increase in the energy. You should make these points. Right? If you see this equation, the whole story can be explained. The whole story can be explained. Got my point? So ಹಾಗಾದ್ರೆ what will happens to the atomic number? What will happens to the atomic number? Say for example, I have hydrogen. All these things will help you in your competitive exams. Please remember. And I have helium. Hydrogen and helium. Right? So hydrogen atomic number is 1. Helium atomic number is 2. That means helium will have 2 electrons. Hydrogen will have only 1 electrons. Now in that case, to avoid the confusion, I will make 2 lines here also. So in that case, can you tell me which particular electron, whether this one or whether this one, will have the higher energy? Which particular electron, whether electron present at energy level 1 in hydrogen or electron present at energy level 1 of helium, which will be having higher energy? Anju, it is hydrogen. Yes, it should be hydrogen. That is because energy and atomic number, they are directly related. But the problem here is negative value, negative sign. So as there is an increase in the value, energy is going to decrease. Got my point? Since there is a negative sign. If there would have no negative sign, yes, as there is increase in the Z value, E value would have increased. But that is not happening. Please remember all these things, it will going to help you out. Rohan, it should be hydrogen. Okay na? So that's where we have the relation between energy level and energy. That's where we have the relation between atomic number and energy. Don't worry about Rydberg's constant. It is a constant. It will be same for all the element. Don't worry. And the value they will only give. All of you have understood? So that's where we have the relation. So therefore, I can make another statement as there is a increase in atomic number. As there is an increase in atomic number, energy will decrease. Energy will decrease. Fine? All of you have understood? Okay? Yes, it should be hydrogen. All of you have understood? Everything is due to this negative sign. And don't forget that you have to put a negative sign. If you have understood this one, I will move to the next one. All of you have understood? Any doubts? Okay. Fine. So, but one thing I have observed, only few students will be responding. What about others? Because I can see the number, it will go up to sometimes 50 and all. Now, how much truth value that will show, I don't know. But it will show up to 50 and all. But only few students, they will be responding to my question and all. Please, even others can respond. Whether it is right or wrong, that will be secondary. Okay? So that's where we have the energy and atomic number, energy and energy level. Okay, done. Hagadre, we will move to the next one. That is, we are going to have hydrogen spectra. We are going to discuss about the hydrogen spectra. So we have to find the equation. We have to find the equation, and it is very, very, very important. So one thing is that some of the topics might be removed. Some of the topics might be removed. So Pavan, what is that? No sir, you have not understood? Whether you have not understood? Okay. So now when I am talking about equation, okay, done. Thank you. So in that case, when I am talking about, now I am not thanking him because he told he has understood, not for that, since he has responded. Okay, done. So ಹಾಗಾದ್ರೆ when I am talking about hydrogen spectra, when I was telling this one, I told that since COVID is going on, some of the concept it can be removed. We don't know. NCRT has told something, but still our board, means Karnataka board, they have not responded. But whatever it might be, I am teaching all these things, but anyway, these cannot be removed. Okay, so that's why we have the hydrogen spectra, which is very important, and you can expect it for 3 to 4 mark question. Okay, even for competitive exam, you can expect the problem. Even in your board exam, you can expect the problem on this. Okay, so now to have the hydrogen spectra equation, first we should know this basic equation. Okay, now I will go. Please, once again I will repeat. Yesterday also I told. Whenever hydrogen spectra, college maybe next month, but not sure. Okay. So with respect to hydrogen spectra, okay, with respect to hydrogen spectra, higher energy than other elements. Sir, then hydrogen consists of higher energy than other elements. But hydrogen is having only one electron. If you consider only that electron present in energy level 1, yes, you are right. Ignish, you are right. But altogether if you consider, other elements have more electrons. Okay? But otherwise if you focus on only one electron, which is present at energy level 1, it's a very good question. Yes, it will be true. Yes, hydrogen, that electron will be having higher energy compared to other element. Yes. Okay, so are the line spectra of hydrogen gas or molecule? So hydrogen molecule or hydrogen gas, one and all same. It will be H2. Okay, so in room temperature, hydrogen molecule will be present as gas. That's all. Okay, now. So this equation you should know. And please, in your examination, if they ask about hydrogen spectra, don't derive the equation. To make you help in solving some of the problem, if they ask in competitive exam and all, I am deriving the equation, but no need of deriving the equation in board exam and all. Okay? Now, since we are talking about absorption or emission spectra, where moment of electron at different energy level will happen, so we have to find out the difference in the energy level. The difference in the energy level. That's why I will get EF minus EI. Final energy level and initial energy level. Got my point? Now, therefore, delta E is equal to, EF means substitute this value. So, minus RH Z square divided by I will write it as NF square, right? Now substitute for EI minus EI, substitute this value, but don't forget that there is a negative sign. So I will put the bracket minus RH Z square divided by NI square, right? Anyway, final unit will be joule only, no doubt. Okay, final unit will be joule only. Now, delta E is equal to, so minus minus, it will become plus RH Z square divided by NF square plus RH Z square divided by Ni square, joule. Got my point? So minus into minus, it will become plus. So therefore, I will rearrange the equation. Positive I will take here, negative I will take it that side. So RH Z square divided by Ni square minus RH Z square divided by NF square. All of you will agree? Joule. Unit will be remain there. So I have just taken positive value this side near to the equal sign and negative value on the other side. Now if you observe it carefully, RH and Z square, they are common in these two. So I will take it outside. So therefore, delta E is equal to RH into Z square multiplied by 1 by Ni square minus 1 by Nf square joule. This is the equation. This is the equation with respect to energy. So this is the equation with respect to energy for hydrogen spectra. For hydrogen spectra, or to be more specific, if you want to talk about hydrogen, for hydrogen Z is equal to 1. All of you will agree? For hydrogen Z is equal to 1. Atomic number is equal to 1. So therefore, same thing I can write it as delta E is equal to, minus I wrote, minus will not be there. So delta E is equal to RH multiplied by 1 square. I am not going to write. Directly I will write this one. This is more appropriate or specific equation for hydrogen only. That is for any element, but this is for hydrogen. So what happened to Z? Z is 1 for hydrogen. So 1 square is nothing but 1 only. So no need to mention here. So directly I have written this equation. All of you have understood? So if you are writing this one for hydrogen spectrum, you have to mention that for hydrogen Z is equal to 1. That's it. Or you can directly write this one. No need to worry. You can directly write this equation. All of you have understood? Fine. Any doubts? Okay. So this is where we have the equation in terms of energy. In terms of energy, this is the hydrogen spectra equation with respect to difference in the energy. Okay, difference in the energy. Now, if I want to express in terms of frequency, I have written in terms of energy. Anyway, in your board exam, you can write any one of these three equations. I am going to write three equations. Any one you can write. Okay. But for competitive exam, they can ask problem on any of these equations. So in terms of frequency I want to express, I will write or I will use this equation. E is equal to h nu, where therefore nu is equal to E by h. Nu is equal to E by h. Okay, Yagnesh. So we will solve the problem, but before that we will finish it off. You want to have to solve some problems based on frequency and wavelength. Okay, we will solve it, Yagnesh. No doubt. We have to solve. So E is equal to h nu. So if I want to rewrite the equation, nu is equal to E by h. Got my point? Now substitute the E value. Substitute the E value. Therefore, nu is equal to, what is that E value? That is RH. I will take divided by h here only, multiplied by 1 by Ni square, 1 by Nf square. Okay. Now, please remember, so Rydberg's constant and this is Planck's constant. H is Planck's constant. Rydberg's constant is having unit as joule. Planck's constant is having joule per second. Planck's constant is having joule second, not per second, joule second. So naturally joule will get cancelled. What is left over? Left over is per second as the unit. Per second when I am taking the frequency. Or since per second is there, even I can use the another unit. Can any one of you tell me which is that another way to express per second with respect to frequency? During frequency I have told which is that one. Which is that one? For frequency, per second, or we can write it as We can write it as, yes, it is hertz. Yes, more appropriate is whatever Likita she has written. Yes, it can be hertz. Okay, so observe it carefully, units. There it is joule because of the Rydberg's constant. Since there is a Planck's constant, joule divided by joule second. Joule will get cancelled. Since it is in the denominator, if I take it up, it will become per second, which can be written as hertz. So another equation for hydrogen spectra. Another equation for hydrogen spectra. Right? So in terms of energy, in terms of frequency. Now in your textbook even they have given with wave number. They have given with wave number. Okay, we have another term called as wave number. Okay, so whenever wavelength is large in size, they will go with the wave number. So the relation between wave number and frequency is wave number is equal to frequency divided by C. Wave number is equal to frequency divided by C. All this equation you should know. Wave number, it will be represented by one line above the symbol. So wave number is equal to frequency divided by C. Okay. So what is C? Speed of light in vacuum. So that is 3 into 10 to the power of 8 meter per second. Right? Because we are dealing with the speed. Right? So hagadre when I am talking about wave number, put the value of frequency. So that is RH divided by H and divided by C, and 1 by Ni square minus 1 by Nf square. Okay. Now RH joule, this is joule second. Okay, we will see the unit, don't worry. Same thing, if I rewrite RH divided by Hc, 1 by Ni square, 1 by Nf square, what can be that unit which we can write? So what can be that unit which we can write? Anyone? What can be that unit? So RH joule and H joule second, right? Then this one speed of light meter per second. What will happen? So this one will get cancelled. Per second will get cancelled. What is left over? Per meter. So the unit will be per meter. Okay. Hertz was missing. Hertz will not come here because we are dealing with not with energy. Ullas. Okay. We are not dealing with the energy. So we are talking about frequency. Okay. All of you have understood it should be per meter. So this can be the another equation for hydrogen spectra with respect to wave number. All these three equations is given in your textbook. All these three equations are given in your textbook. So I will remove this. Since we are dealing with hydrogen spectra, you should not get confused. I will remove this. Okay. So these are the equations which we can write. Here also, any one equation we can go with. I will remove upper one. Per second I will remove. Okay. So no need to derive. Okay. So no need to derive. If in the examination, if they ask about hydrogen spectra, then you should talk about first what you mean by hydrogen spectra. It is nothing but a line spectra, which is nothing but a line spectra. Okay. Then you should talk about this equation, any one of these three. You can talk about this equation. All of you have understood? Okay. So shall I remove this? Now this is related to equation. But only for equation, definitely, or they are not going to give 3 marks to you. or 4 marks to you, we have to write more things, we have to talk about many things here. Since we are dealing with this spectra, that means there will be a color, different wavelengths we can observe, right? Or colors in the sense wavelengths we can observe. Now when it comes to hydrogen spectra, we can see majorly 5 regions. We can see majorly 5 regions. Okay, Geeta. Now when I am talking about, sir, what is N? N is nothing but energy level. See, for example, I have nucleus, then I have the energy level. Energy level means it's an imaginary line where electrons will be moving around the nucleus. Since those electrons will have the energy, so therefore it will be called as energy levels. Okay, don't worry. So these are the one which will be represented by the N value. So that means small n is nothing but number of energy level. Okay, number of energy level. I will repeat, Geeta. Okay, so now when I am talking about the equation, it is majorly based on energy equation where minus RH into Z square divided by N square joule. This is the equation which you should know. Okay, so you have to practice and don't forget to write about negative sign. Don't forget to write about the negative sign. Chitwan, yes. Now you got the answer. Yes, energy level and orbits will be same. Yes. Geeta, whether you want me to rewrite the equation, derive the equation, or only equation I have to explain? What you want me to do? Because second time I will be a bit fast, so you have to tell me very fast that whether I have to derive the equation or I have to write 3 equations and I will explain it. Anyway, you can answer that. I will be explaining this one. So when I see the energy equation, we can clearly see that energy of any energy level, En means energy of any energy level. Okay, I will repeat up. Okay, so energy of any energy level will be equal to minus RH Z square divided by N square joule. Okay, now if I observe it carefully, En is in the numerator and N is in the denominator, right? E is in the numerator and Z is in the denominator. Numerator in the sense it is on the other side of the equal sign. Okay, so En, N, En, Z. Now I can tell that if there would have not been any negative sign, don't think that there is no negative sign. So what it means, whenever there will be increase in the N value, En value would have decreased. If there is no negative sign, as there is an increase in the N value, En value would have decreased because they are inversely related. Okay, so they are inversely related. I will repeat it. So they are inversely related. But if I take atomic number and En, they are directly related. That means as there is an increase in the Z value, En value would also increase. Got my point? If there is no negative sign I am talking about. Therefore I have removed the negative sign. So En value increases, En value is going to decrease. Z value increases, En value will also get increased. Now, exactly opposite will happen when I will be having a negative sign. Exactly opposite will happen whenever we have the negative sign. Okay? So now, as there is increase in the N value, En value should also increase. As there is increase in the Z value, En value is going to decrease. Exactly opposite because of the negative sign. That one you have understood? So that means when I am moving from one energy level to next energy level, When I am moving from energy level 1 to energy level 2, that means energy is getting increased. Okay? So that is one thing. Now, by considering the equation where En is equal to, where En, I am directly writing the equation, En is equal to RH multiplied by 1 by Ni square minus 1 by Nf square. That's what we had got. All of you will agree? How come, sir? What happened to negative sign? That's what we have seen during the derivation of equation. That's what we have observed. What will happen to that negative sign? Because when we write the equation, before that we have done some process. That is, delta E is equal to EF minus ER. Final energy level, initial energy level. Okay? So that's what we can see. When I am deriving the equation, finally I have got En is equal to RH 1 by Ni square minus 1 by Nf square joule. That is one equation in terms of energy. Now, if I make it into frequency, because E is equal to h nu. So therefore, nu is equal to E by h. All of you have understood? E is equal to h nu. This equation, yesterday's class only, day before yesterday only we have discussed. By rewriting the equation, nu is equal to E by h. So by using this equation, we are going to fill the values. E value, everything is nothing but E value only, right? So therefore, RH divided by h, rest of the things will remain same. 1 by Ni square, 1 by Nf square. Now the unit. Since we are talking about frequency, frequency is nothing but number of cycles per second. It should be per second, number of cycles per second. So same thing we can prove here also. RH unit is actually joule, and Planck's constant unit is actually joule second. Now joule will get cancelled. Since here it is n to the power of 1, which we are not going to represent, we are going to write it as only second. If I take it on the top, it will become per second. All of you will agree? So therefore I will mention it as per second or hertz, not divided by, it is or. Any of these units we can represent. Per second or hertz. One and all same. Hertz means cycle per second only. Okay? So next one, last, if I want to express in terms of wave number. Now to write that one, we should know the relation between wave number and frequency. That is C, nu by C. Wave number and frequency, they are directly related to each other. Okay? So by substituting the frequency value, what is that frequency value? This whole thing. So therefore, RH divided by H multiplied by 1 by Ni square 1 by Nf square. Now divided by, what is that? Speed of light. Speed of light, C. Now RH is joule. Anyway, that unit we have per second already, but still I am writing joule. And H is nothing but, this will come down, right? Because if I write it here, RH divided by Hc, because it will come down, 1 by Ni square 1 by Nf square. Now joule second, then meter per second. Why meter per second? Because C is speed of light. Speed is having equation, or also the, should we remember only equation, no derivation. That's what I am telling Yagnesh. No derivation. Don't remember the derivation. Means if you know, no need to worry, but to write it in the exam, no need to remember. Okay? So only equation you should know. So that's where meter per second, joule will get cancelled. Since it is positive 1, minus 1, it will get cancelled. So left over is meter actually, right? So if I take it on the top, plus 1 will become minus 1. That's where per meter. So therefore we have the three equation, 1, 2 and 3. Among these three, any one you can write. Not even all the three. Any one you can write, but only thing is you should mention in terms of energy, or it is in terms of frequency, or it is in terms of wave number. Any of these three, but you should mention what is nu slash, that is what is that one, that is wave number, or what is nu, that one you should mention with proper unit. With proper unit. Without unit, value will not have any weightage. Okay? Until unless that will not have any proper SI unit. For example, atomic number, it's just a number, no unit. Energy level, it is just a number, no unit. Okay? All of you have understood? So this is where we have the equation. Any doubts? Okay? Along with this equation, now you should talk about what is that spectral region, different energy level region, right? Say for example, when I was talking about continuous spectra, where different wavelengths will get separated, right? So with Gaia. So why they are having different wavelengths? Since they are having different wavelengths, they will have different energy also. Same logic is applicable here. Even in line spectra, different energies will get separated. But only thing is there will be clear demarcation. Okay? So we can have the different energy of radiation. Each energy of those radiations will be named with a person. Okay? So it will be named with a person. That's where we have L, B, P and BP. Yes sir. Low blood pressure blood pressure antana ನೆನ್ಪಿಟ್ಟುಕೊಳ್ಳಿ ಹಾಗೇನೆ. ಓಕೆನಾ? And this is how it has to be arranged. Anything should not be reversed. Okay? Now I will complete it. That is nothing but Lyman. In the exam don't write single word. Okay? So to make you understand, I am writing this one. So B stands for bomber. B stands for bomber. P stands for passion. P stands for passion. Don't write pasture, Louis Pasteur. No, his contribution is related to microbiology, not here. Biology students will be knowing. So it is passion. Okay? Then bracket. Then P-fund. Then P-fund. Okay? So that's where we have the different energy level, or we can call it as different series of energy. We can call it as different series of energy. Please remember, don't write these single words. You should write this one. So to make you remember, I have written like this. Okay? So if you remember Lyman, Balmer, Passion, then rest of the things you can write L, B, P, BP. Only thing here is they have similar initial word. Okay? So that's why we have the Lyman, Balmer, Passion, bracket, P-fund. Position should not be interchanged. You are going to lose the marks. Definitely you are going to lose the marks. Now, in this case, Ni, initial energy level, and final energy level. Initial energy level and final energy level we are going to write. Now when it comes to Lyman series, I will explain it once again, don't worry. Ni value, it can be 1, that means energy level 1. Then energy level 2 will be either 2 or 3, or it can be anything. It can be anything. Okay, final energy level. Now when it comes to Balmer, it will be energy level 2 will be the initial energy level. Final energy level can be 3, 4 or it can be anything. But it should not be 2. Okay? So now energy level 3 in case of the passion. Now it will be 4, 5 and it will goes on. Okay, same logic. 4 here, 5, 6. It can be anything. Then 5, it can be 6, 7 or it can be anything. But not 5 or less than 5. Not 4 less than 4. Not 3 less than 3. Not 2, not less than 2. Like that it should be written. NFL. What I mean to tell here is, if you observe it carefully, this table you have to give. In the exam also you should give the table. Now what I have written, I will explain it here. Even this diagram you can draw in the exam also. So this is n is equal to 1. Now this is where we have the n is equal to 2. So this is where we have the n is equal to 3. So this is where we have the n is equal to 4. So like that we can go on. N is equal to 5. And finally at one particular point we have the n is equal to infinity. N is equal to infinity. So we are not worried about n is equal to infinity. We are not interested in that. Because those electron is not available which will go to infinity. Okay? So therefore, when I am talking about Lyman, initial energy level was here, n is equal to 1. Now it can go to 2, it can go to 3, it can go to 4 or it can go to 5, anything. All of you are understanding? When I am talking about Lyman series, n is equal to 1. So it can go here or it can go here or it can go here or it can go here. Got my point? So when it comes to Balmer, n is equal to initial electron will be here. From here it can move here or it can move here or it can move here. When it comes to passion, initial electron was here. From here it has jumped to here or it has jumped to here. When n is equal to bracket series, where it will be here, from here it will move here. All of you have understood? So that's what it indicates. Hagadre, whenever this electron will move to such a higher energy level, and I told they will come back. They will come back. They will come to ground state. This will be the ground state because hydrogen atoms, they have only one electron. Hydrogen atom, they have only one electron. So therefore, electrons ground state is nothing but they should be present at energy level 1. So whatever other energy level they have moved, they have to come back. If electron has moved here, it has to come back to its ground state. So that's where it will give the emission. So absorption, now emission. Anything is fine. Absorption, that is hydrogen spectra, that is related to absorption, or it can be emission. Okay? So what I will do is, whatever is there in your textbook, I will take that one. That is, they have given, if I am right, they have given emission. So that means electron from this energy level, it come back to here. From this energy level, it will come back to here. From here, it will come back here. Or from here, it will come back here. Or from here, it will come back here. Right? So that's what Lyman spectra. That's what Lyman spectra. From energy level 1, it has moved to different energy. Now they are coming back. So that's where we have the Lyman spectra. Now when it comes to Balmer, now it will be like this. Balmer. Got my point? Now it will be like this. This is Balmer. Okay? Now, passion. So from 3 it has moved now. So therefore it will come back to 3. It will come back to 3. So this is called as passion. Okay? Now, bracket. So for 4, it has moved from here, right? So from there it will come back to 4. So that's 4, we have the bracket. Same way for P-fund. So it has moved from here, so it will become, or it will come back here. Even from higher energy also it will come. I have shown only up to n is equal to 6. So that's what this indicates. All of you have understood? Any doubts in this? All of you have understood? So it is only valence electron will get excited? No. No. It depends on the source of energy. Okay? Valence electron will be exposed first, no doubt, but even other electrons can also. But inner shell electrons, they should require more energy. Low blood pressure, sir. Yes, that's what I told. Okay, now? But don't write that one in examination. Fine? So you have to represent this one and this one. But another important thing is that, because when it comes to electromagnetic spectra, gamma rays will come here, X-rays will come here, then comes the UV, then comes the visible, then comes the infrared, then comes the microwaves and radio waves. Like this it will go on. So what I mean to tell here is, yes, I will teach you. So what I mean to tell here is, when you move towards the left side, energy is going to increase because frequency is going to increase. When you are moving toward the right side, energy is going to decrease because frequency is going to decrease. That means wavelengths are getting decreased and wavelengths are getting increased. All of you have understood? So that's where we have the electromagnetic spectra. So gamma rays, X-rays, UV rays, visible rays, infrared. So for time being, we will not bother about microwave and radio waves. Radio, FM and AM, right? FM is bit higher frequency compared to AM. Okay? So anyway, radio waves. Radio waves will be of low energy. We cannot have high energy with radio waves because we are listening FM radio, right? If radio waves will become higher energy, all of us would have suffered from cancer or any other disease. That will not happen. Don't worry. Radio waves, nothing to do. Now when it comes to these radiations, that's where I am interested in visible and infrared, because hydrogen spectra falls in that region, visible and infrared. Yes, left side frequency will increase, right side frequency is going to decrease. Yes, absolutely correct. So same logic for energy also, but inverse for wavelength. Left side wavelength is going to decrease, right side wavelength is going to increase. Absolutely correct. Okay? Hagadre, you should tell me among these, which series can have the highest energy? Which series? Diagram is here, table is there, last one information you should give. Which series will give highest energy? Whether Lyman series, Balmer series, Passion or Bracket or Priffon, which series will give the highest energy? Or it belongs to, which one belongs to highest energy? Oh, Stefan and Ullas, very good. It should be Lyman series. Absolutely correct. If you observe, see the difference here, too high difference in Lyman. That means that much energy is getting released or getting absorbed. Yes, that's where we have the Lyman series, which will belongs to UV region. Okay, so here I can tell electromagnetic spectra, which belongs to which spectra? Electromagnetic spectral region. Okay, so that's where it belongs to. Lyman belongs to UV, which can be of low frequency or which can be of low energy. Then now it is easy. Which can be of low energy? Among these five, which will be of low energy? Lyman, highest energy. Yes, UV. Yes, it should be defined. So which will be in the infrared. Okay, so don't worry, it's very simple. When it comes to bomber, it will be visible. Okay, which we can write it as vis. And this is also infrared, this is also infrared. Okay, so that's where electromagnetic spectral region it belongs to. Okay, hydrogen spectrum. So first you should tell what you mean by hydrogen spectra. You should tell that it is a line spectra. Then you should tell about this particular table where we have Lyman, Balmer, Pasteur, Brackett, Biffin series with respect to different spectral region. Okay, so then you should explain with this diagram. Okay, so this diagram might not be compulsory, but this is compulsory, equation is compulsory. So you can explain with this diagram, and at the end, last you can tell, because hydrogen spectra is a light spectra. It can be absorption or it can be emission, whatever it can be, right? So therefore, last one sentence, with respect to absorption spectra, with respect to absorption spectra, we can mention that EF with respect to absorption spectra, EF will be smaller than that of the EI. EF is greater than that of the EI. All of you will agree? EF will be greater than that of the EI. Therefore, energy will be absorbed. Therefore, energy is absorbed. Energy is absorbed. And another sentence is with respect to emission spectra. With respect to emission spectra, EF will be smaller than that of the EI. EF will be smaller than that of the EI. Therefore, energy will be released. Energy is released. That's why we have completely written hydrogen spectra. Got my point? So if you observe the table, they are talking about absorption. If you see the pictorial representation, they are talking about emission. Right? So from higher energy it is come back to the lower energy. But here from lower energy it is going to the higher energy. So you can write the same picture also, where all these arrows can go towards upward, but it will become absorption then. Okay? So to avoid that, you can write this table, you can remove this diagram. It may not be compulsory, but this sentence you should write. Last sentence you should write. All of you have understood? So that's where you are going to get complete marks. Equation, table and this sentence. They are going to get complete marks for hydrogen spectra. And even in equation, any one equation is more than enough. Okay? Any doubts in this? So today you can practice hydrogen spectra from your textbook, NCERT book. Whatever I have given, exactly I am following NCERT book only. I don't think I am deviating from that. Okay? So you can go through that textbook once again. You can practice and you can come back on Monday. And if you have any doubts, let me know. And even now, whatever I have explained, all of you have understood, or any doubt to anyone, anything, you can ask. Anyone, if they are having any doubts, you can ask. But it's very important, hydrogen spectrum. Any doubt? So what and all you are going to write? Hydrogen spectra. It is nothing but a line spectra. It can be related to absorption or emission spectra. Then you should talk about equation, no derivation, only equation. It can be related to energy, it can be related to frequency, or it can be related to wave number. But be careful about the unit. Then you should talk about the spectral region with the name. and the last one is this sentence. Okay, so by this you are going to get complete 4 marks. For that table itself it will be more marks. Okay now? Done? Any doubt? I think someone I saw, they were asking some doubt, na? I will just see in the beginning itself. Someone was asking for me to repeat. Chidwan. Okay. So I'm not getting the name. Okay, Geeta. Have you understood, Appa? Not only for Geeta, but I think she had asked me to repeat, but even for others also. Have you understood? Okay, okay then. In that case, I will stop here. So Monday we will continue. But you have to practice. Okay? And Monday we are going to solve, we are going to have Bohr's atomic model, which is also very, very important. Then we will solve some of the problems. Okay, Geeta. Thank you. Okay, bye then. Thank you. Take care.